Alright, welcome to chapter 6.2, where we're going to talk about a new kind of chemical bond, the covalent bond. I covered a lot of information in the ionic bond video, so I'm going to try and make this one shorter. A covalent bond is a chemical bond, just like an ionic bond, but it's when two atoms share a pair of electrons. So this is totally different than an ionic bond, where the electrons are actually transferred from one atom to another. In the ionic bond, an electron moves from the outer valence shell that is pretty empty on one atom to an outer valence shell on another atom that's pretty full and looking to gain 8 electrons in its valence shell, or 2 if it's helium. A covalent bond, on the other hand, these electrons don't actually get transferred. They just get shared between those two atoms. And covalent bonds occur between nonmetals. When these groups of atoms are neutral, they're called molecules. So a molecule is a neutral group of nonmetals that are bonded by covalent bonds. Now, the reason covalent bonds work is similar to ionic bonds. It's all about electric charges. In an ionic bond, a positively charged ion that has gotten rid of an electron is attracted to a negatively charged ion that has gained an electron. Opposites attract, so they are pulled together, and that's what holds that chemical bond together. In a covalent bond, the electrons from each atom are not only attracted to their own nucleus, because electrons are negative and protons are positive, they're also attracted to the nucleus of the other atom. So even though no electrons are exchanged, the driving force between covalent bonds is still a positive attracting to a negative. So this nucleus of this hydrogen is not only attracted to its own electron, it's also attracted to this electron, which is what pulls this electron over toward it. Same thing with the other atom. And that's why these two electrons end up being shared by these two atoms to create a full valence shell. Now, not all covalent bonds are created equal. And this is because some are stronger than others due to the number of pairs of electrons that get shared. So we can do an electron dot structure for all of the elements in a covalent bond just like we did for an ionic bond. If we take a look at the periodic table, we can try and do electron dot structures for fluorine, and then oxygen, and then nitrogen respectively. So if we look at fluorine, fluorine is over here in group 17, meaning it has 7 valence electrons. So if we take a look at these two fluorines next to each other, we've got 7, 1, 2, 3, 4, 5, 6, 7. Now, in order for this atom to have 8 and this atom to have 8, there's a really simple solution. They just have to share these two electrons between them. Now, we can count this electron over here to make 8 and this electron over here to make 8. They're being shared. Now, this pair of atoms is sharing 2 electrons, and this is what we call a single bond. When 2 electrons are shared, it makes one single chemical bond. Now if we look at oxygen next, oxygen is over here. It's in the 16th group, which means that it has 6 valence electrons. So if we draw the dot structure for these, we have 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. And if we think about, okay, we want these oxygens to have 8 electrons in their outer shell, they can't just share 2 of them, because if they share 2, then each of these is only going to have 7. So what they need to do is they actually need to share between them 2 pairs of electrons. And my pen is just not digging this right now, apparently. So with oxygen, in order for both of these oxygen atoms to have a full valence shell at 8, they need to share between them 4 electrons. This is twice as many as in fluorine, where they shared 2, so we call this a double bond. And when we do nitrogen, nitrogen has 5 electrons in its valence shell. And by doing out the electron dot structure, you'll find that in order for nitrogen, both of these to have 8 valence electrons, they have to share between them 6 electrons. Sharing 6 electrons is 3 times as many as they shared over here between fluorine. So this is what we call a triple bond. Now, playing with the electron dot structures and manipulating the electrons to make sure you have a covalent bond or an ionic bond, and whether it's a single, double, or triple, we'll do a lot of practice with that. By the way, these right here are called diatomic molecules because they have two atoms. And this is how these atoms, or these elements, exist in nature. So the oxygen we get out of the air is actually chemical formula O2 because it's two oxygen atoms bonded together by a covalent bond. Now, not all atoms share the electrons equally either. So not only do we get single, double, and triple bonds, we also get something called polar molecules with covalent bonds. So the desire for an atom to get electrons is called its electronegativity. If it really, really, really wants to get those electrons to fill its outer shell, it's very electronegative. If it wants to get rid of them, and it doesn't want to gain those electrons, it has a very low electronegativity. So depending on the electronegativity of the atoms you have together, if one is more electronegative than the other, if one wants the electrons more, it'll form a lopsided looking molecule, and that's what we call a polar molecule. So fluorine, if you remember, has 7 valence electrons. It needs to get one more to get that full valence shell that it wants. So it really, really, really wants those electrons. It has a very high electronegativity. Hydrogen, on the other hand, it might be easier to give that electron away than to gain one, and so it doesn't really want that electron that badly. So the electrons tend to be pulled toward the more electronegative element, making it this weird lopsided shape. Now, in this shape, it turns out that this side of the molecule is actually more negative than this side. This side is slightly positive, and this side is slightly negative, because we can think of all of the little electrons as crowding over on this side. And if all the little electrons are crowding over here, we've got more negatives over here than we do positives, which leaves more positives over here than negatives. So this end is going to be positively charged, and this end negatively charged, and this end will be positively charged. So those are covalent bonds. Let me know if you have any questions, and here are your homework questions.